Good day, guys. You're welcome once again to another exciting video lesson on Maestro Science Guide. As you all know, in this channel, it is strictly for science students. All right, you're offering chemistry, biology, or physics in your examination, or you have challenges with these subjects. All right, you're in the right channel. Stay glued to this channel, and you will see all of these subjects be demystified in the most simplest manner. All right, now if you are new to this channel, please, I want you to click the subscribe button, turn on the bell notification. All right, so in today's video lesson we are going to be looking at writing chemical formula. How can you be able to write chemical formula as a chemistry student? All right, how are you able to write chemical formula as a chemistry student? All right, now your ability to write chemical formula will save you in a lot of aspects of chemistry, especially the area of chemistry known as stoichiometry. If you're able to write chemical formula, concepts like stoichiometry, even other stoichiometric concepts like calculating percentage composition, all right, of a compound. Now all of these concepts will be very easy for you if you know how to write chemical formula. But if you don't know how to write chemical formula, please don't be scared. All right, you have the secret here. And if you already know how to write chemical formula, you can still stay tuned in this video lesson. All right, you never can tell, you might get or learn one or two things, all right, from this video. Okay, now before you talk about writing chemical formula, there is a particular thing you need to know, and that is the different ions or radicals that we have in chemistry. All right, there are so many, but there are a few common ones. All right, now if you can know these common ones, you have scaled through already throughout your O-level examinations. All right, now what are these common ions or radicals? They are the positive ions or positive radicals, and then the negative ions or negative radical. Now I want to show you quickly, all right, the table for these radicals. Right, so when I bring them out, all right, so you're going to learn, you're going to see it, and I want you to master it to the best of your ability. Learn it to the point that you don't need an assistant, any book. All right, you'll be able to put it down. Okay guys, so we have on the board ion slash radical, IUPAC name, and then valency. All right, now what is valency? Valency basically is the combining power of an atom or an ion, or you can say radical. So that's valency, the combining power. All right, now valency sometimes can also be used interchangeably to mean oxidation number or oxidation state. So I'll give you an example of what I mean. So what I mean is, if you see this Na plus sodium ion, the valency is what? +1. When you want to also get the oxidation number or the oxidation state of Na plus, that's sodium ion, it is still +1. So some occasion valency corresponds to what? The oxidation number. All right, now it's mostly work for just simple ions. Okay, simple ions like this. So what's the valency of this? +1. What's the oxidation state? +1. Valency of this? +1. Oxidation state? +1. Valency of this? +2. Oxidation state? +2. Valency of this? +3. Oxidation state? +3. But in this case now, when an atom, what's the oxidation state of nitrogen in this compound? These ones are just simple ion, they are just a single element, like this guy too, just a single element. But this one is group of atom, just a single atom, single atom, single atom, single atom, single atom. But yeah, we have group of atom. This is a group of atom. This is a group of atom. This is just a single atom. This is a group of atom, and also this is also a group of atom. So for these single atoms, all right, their valency corresponds to what? Their oxidation state or oxidation number. So now these are not everything, all the ions or radicals. Now the ones that are ions, these, no, these, then this and this, then others are radicals. Now the radicals are basically the ones with two or more atoms grouped together. So this is a radical, this is a radical, this is a radical. Alright, this is a radical, this is a radical. Okay, so now having talked about this, now you need to learn this, right? You need to have it, all right, upstairs. Okay, so you need to know this is sodium ion, hydrogen ion, calcium ion, aluminium ion. So know them, the IUPAC name, and the valencies. All right, so why is it important for you to know the IUPAC name? In case, all right, you want to write the name of the compound, or you're given the name of a compound, you're told to write out the formula. For example, I tell you, write out the formula for hydrogen tetraoxosulfate 6. You can see tetraoxosulfate 6. So tetraoxosulfate 6, this is it. All right, you can see it. This is tetraoxosulfate 6. So you now know that, oh, I need to use the tetraoxosulfate 6 ion and then the hydrogen ion. Are you getting it? So at this point now, I want you to pause this video right now, and please put all of these down. All right, put all of these down. Now if you've done it, okay, then let us proceed. Let us take this question for example. Now there are rules to this writing of chemical formula, but before you look at the rule, let's read the example on the board. It says, write the chemical formula for calcium triazole nitrate 5. Now if you remember the table I gave to you previously, calcium triazole nitrate 5, so it's already telling us that there are two things here, right? What are the two things here? The first, we have what? Calcium, right? So write out the ion for calcium. What did I tell you is the ion for calcium? 2 plus, Ca2 plus. So Ca2 plus, then write out our triazole nitrate 5, which is what? NO3 minus. Now this thing I just did, it corresponds to rule 1. What does rule 1 state? It says write the ions present in the compound. So in the compound calcium triazole nitrate 5, what are the ions present? Calcium ion and what? Triazole nitrate 5 ion. So wrote out the ions present. Now take note, in trying to write out the ions that is present in the compound, make sure that the positive ion, which is called a cation, take note, a positive ion is called what? A cation. All right, so the positive ion, the cation, must be to the left side, the left hand side, while the negative ions, which is the anions, all right, so negative ions are also called what? Anions, while the anions, so they will be placed where? On the right. So that is why I put the positive at my left, the negative at my right. You can see it, left, right. Okay, so now if you look at rule 2, says if the number of valencies on the cations and anions, so cations and anions, if the number on the if the number of valencies on the cation and anion are the same, if the numbers are the same, what do? We cancel out. Now are they the same? Remember, calcium is what? 2 plus, that's plus 2. Triazole nitrate 5 is what? Minus 1. Don't forget from our table. All right, so are they the same? 2 and 1, are they the same? No. Please pay attention. We are not looking at the charge here. We are not looking at the positive or negative. No, we are looking at the number. Look at it. If the number of valencies, so it is number, not if it is positive or negative. We are looking at number. All right, so because this is 2 and this is 1, we know that this is plus 2, this is minus 1, but remove the plus and minus. That's not our concern. What concerns us is the number. So here is 2, here is 1, so it means they are not the same. So if they are not the same, what are we supposed to do? Now if they are not the same, then we exchange their valencies. So this is 2 and this is 1, they are not the same. So since they are not the same, what do? We are going to exchange their valencies. So how do we do this? Very easy. Let 1 come this way and let 2 go this way. So by the time 1 comes, we have Ca Now, because this is 2, all right, and this 2 is affecting everything here. It's not only affecting the oxygen. Because I brought the 2 here, don't say, okay, 2 times 3, 6. And you're not going to do something like this, CaNO6. No, it's wrong. All right? So, these guys, they are going together. NO, they are going together. Okay? So, because they are going together, we'll now put them in brackets. The 2 is affecting it in bracket. So this 2 is affecting all of them in the bracket. So that's why we put them in the bracket, parentheses. Okay, put them in parentheses. So this is the formula, the chemical formula for calcium triazonitrate 5. You can see how we did it. So by the time we cross, now if assuming this one was also 1, remember here is 1, here is 1. If assuming here was 1, so 1 1, they are the same, so we would have cancelled out. But because they are not the same, so that is why we have to exchange. So 1 came here, anything that's 1 is that same thing. So there is no need of putting, there is no need of saying we want to put 1 here, right? Makes it wrong. Just like in mathematics, you cannot say 1x, right? You just call it what? X. So same thing here. You cannot do Ca1. You just put it as what? Ca. So calcium. All right. Now let's look at 2 more examples. Okay, class. Now let us look at example 2 and 3. Example 2. Write the formula for ammonium triazonitrate 5. We want to write the formula for ammonium triazonitrate 5. So if you remember, now first thing first, we need to write the positive, all right, to the left, the positive ion to the left, and then the negative ion to where? To the right. All right. So remember, ammonium ion is what? NH4 plus. That's the positive. Then our triazonitrate 5 is NO3 minus. So now, like I told you, we are not looking at which is positive or which is negative. We are not talking about if the 2 is positive or 1 is positive, 1 is negative, or if both of them are negative. No, what we are looking at is number, not the sign. We're looking at the number, not the sign. Take note. All right. So for the number, here is just positive. So here is 1, saying plus 1. Here is just negative. That's what? 1 minus 1. Are you with me? So 1 cancel out 1. Why are we cancelling? Look at it. If the number of valencies on the cations and anions are the same, cancel out. All right. So the number here is 1, and here is also what? 1. So irrespective of the sign, we are not looking at the sign, just the number. So number 1 cancel out 1. Therefore, all right, the formula becomes what? NH4NO3. This is the formula for ammonium triazonitrate 5. This is it. All right. Then we also have example 3. Says write the formula for aluminium hydroxide. So how do we write for aluminium hydroxide? Remember, the ion for aluminium is what? Al3 plus, right? So that's 3. Then hydroxide is OH minus. Okay, so we are not looking at the sign, rather we are focusing on what? The number. So here is 3, here is minus 1, which is 1. So here is 3, here is 1. Are they the same? No. So what do? Exchange, right? So 1 comes this way, 3 goes this way. Therefore, the formula becomes what? Al. Now, like I said before, you cannot put 1 here. That doesn't make sense, right? So Al. Now these two are going together. Okay. So you are putting this 3 is affecting both of them, and the only way you can write it to show that it is affecting, the 3 is affecting both of them, all right, is to put it in brackets. Now if you do not put it in brackets, you just write it as OH3. What you just said now is that what this is telling us is that this 3 is only affecting the H. Meanwhile, OH are going together. They are functioning. That's the radical. They are functioning as 1. Okay, both of them are going together. So in order to show that the 3 is affecting both of them, which is they are the radical. So do like this, OH3. So this is the formula for aluminium hydroxide. All right, now if you have gained information from this video, if you've learned something, please do that to like, subscribe, turn on your notification bell, and drop a comment on what you think about this video. All right, now I want to give you guys a classwork, and I want you to do it for me. This is your classwork. All right, write the chemical formula for sodium hydroxide, copper tetraoxosulfate 6. Please do this and drop your answer in the comment section. All right, so thank you very much for watching. Please like, subscribe, and share this video to your friends, and I will see you in the next video lesson.